Alright, so seven's a little different because it's not a function, it's a circle. So for circles, so circles are, as equations, is when you have x and y squared. And you can actually have something that you'll learn about probably next year called an ellipse, which is like a circle, but where like one diameter is longer than the other diameter. And that's going to happen when there's coefficients in front of x squared and y squared that are different. So like if there was a 2 here, then there wouldn't be a circle, but if there's a 2 here, it would be a circle. Or you might remember some of that from geometry, but I'm getting ahead of myself there. So what I'm trying to say is if you have an equation where it's x squared and y squared, you should just, the best way to know how to do this is to know the general form of a circle is x minus h squared plus y minus k squared equals r squared, and h and k is the center of the circle and r is the radius. So in other words, like whatever makes this inside these parentheses, that x value, whatever makes that 0, so 4 is going to be the x coordinate of your center, and whatever makes like what's in these parentheses that aren't there, so the y, whatever makes y 0, so 0 is going to be the y coordinate of the vertex. So we have the point 4 comma 0 is our center here, and then this is just the radius squared. So since it's equal to 3 squared, our radius is going to be 3. So if you just move 3 up, down, left, and right from the center, then there's your graph right there. So this would, so the parent function would just be like a circle where the center is 0, 0, and the radius is 1. And then the transformations, if you compare it, so if I were to graph this circle in red, it's just going to look like this. So if you were to compare it, it got moved to the right 4, didn't move up or down, and then it got dilated in every direction by a factor of 3 because the radius went from 1 to 3. So if like this, so you take that one, like it gets, triple, all those points get triple the distance that they were from the center. So in your domain of the orange graph, right, it's just between every x value between 1 and 7, and your range is like every x value between -3 and 3. So its range will do y. Alright, so circles are kind of special. I would just know this form, but you could also use transformations. Like if you know what the unit circle looks like, right, that's the unit circle, and know, okay, that moves it to the right 4, and that 9 is really like 3 squared. But it's not the same thing as a vertical stretch or horizontal stretch, which is why I said it's good to know this general form. But the 9 is going to make the circle bigger 3 times because the radius tripled in size.